myself Rajendra Karale. My qualification is MSc Chemistry B.Ed and experience is of 28 years. Now, today we are going to discuss about numericals based on collision theory. Here write down type 1. First numerical is a first order gas phase reaction. A first order gas phase reaction has activation energy of 240 kilojoule per mole if the pre-exponential factor is 1.6 into 10 to the power 13 second inverse. Here what is the rate constant of the reaction at 600 Kelvin. Now here write down solution. Given data. Here activation energy is given, that is EA is equal to 240 kilojoule per mole. Convert this from kilojoule into joule, that is 240 into 10 to the power 3 joule per mole. Second, pre-exponential factor is given, that means A is also given here, 1.6 into 10 to the power 13 second inverse. And here to find rate constant K, and here temperature T is also given, which is 600 Kelvin. Now here EA is given, A is given, T is also given, and here find the rate constant. Now here you can use the Arrhenius equation. The Arrhenius equation in the logarithmic form is given as, here log of K equal to minus EA upon 2.303 R into 1 by T plus log of A. That means here log of A minus K log of A minus log of K is equal to EA upon 2.303 R into 1 by T. That means here log of A by K equal to EA upon 2.303 R into 1 by T. That means here substitute the value, that is log of A by K equal to EA 240 into 10 to the power 3 upon 2.303 into 8.314 into 1 by T means 600 Kelvin. That means here log of A by K equal to, now try to calculate this by using the log table and your answer becomes 20.89. Now taking antilog of both sides, here A by K equal to antilog of 20.89. That means here A by K equal to 7.78 into 10 to the power 20. Now here K equal to A upon 7.78 into 10 to the power 20, that is K equal to A 1.6 into 10 to the power 13 upon 7.78 into 10 to the power 20. Here answer of K is 2.055 into 10 to the power minus 8 second inverse. This is the answer of K. Now here write down second numerical. The rate constant for a reaction is found to be 1.96 into 10 to the power minus 2 second inverse at 313 Kelvin. The activation energy of the reaction is 93.26 kilojoule per mole. Here calculate the frequency factor of A. Here answer is A equal to 8.185 into 10 to the power 13 second inverse. This is for homework. Third numerical, the decomposition of A into product has value of K as 4.5 into 10 to the power 3 second inverse at 10 degrees Celsius and activation energy is $60 kilojoule per mole. Calculate the temperature at which the value of K be 1.5 into 10 to the power 4 second inverse, and your answer is T is equal to 24 degrees Celsius. Again, this numerical is also for homework. Now here write down type 2. The rate constant for a first order reaction are 0.6 second inverse at 313 Kelvin and 0.045 second inverse at 293 Kelvin. What is the activation energy? Now here write down solution. Given data, here the rate constant are given at two different temperature. Here K1 equal to 0.045 second inverse when temperature T1 equal to 293 Kelvin. K2 is equal to 0.6 second inverse when temperature T2 is equal to 313 Kelvin. And here to find EA equal to question mark. Now here according to the Arrhenius equation, log of K2 upon K1 is equal to EA upon 2.303 R in bracket T2 minus T1 upon T1 into T2. That means here log of 0.6 upon 0.045 equal to EA upon 2.303 into 8.314 in bracket T2 313 Kelvin minus 293 Kelvin upon 293 into 313. That means here log of 13.33 equal to EA upon 2.303 into 8.314 in bracket 313 minus 293, that is 20 upon 293 into 313. That means here 1.1248 EA upon 2.303 into 8.314 into 20 upon 293 into 313. That means here EA equal to 1.1248 into 2.303 into 8.314 into 293 into 313 divided by 20. That means the answer 98.810 joule per mole. Convert it into kilojoule per mole by dividing 1000. That means here 98.810 kilojoule per mole. Now here the next numerical fifth number, the first order rate constant for the decomposition of ethyl iodide by the reaction CH3 CH2 I gas plus gives CH2 double bond CH2 gas plus HI gas. Now here at 600 Kelvin each 1.60 into 10 to the power minus 5 second inverse. Its energy of activation is 209 kilojoule per mole. Calculate the rate constant of the reaction at 700 Kelvin. Now here answer K2 is equal to 6.36 into 10 to the power minus 3 second inverse. Now this numerical is also for homework. And then next, the rate constant of a reaction at 500 Kelvin and 700 Kelvin are 0.02 second inverse and 0.07 second inverse respectively. Now here calculate the value of EA and A. Here answer first EA equal to 182281 joule or 182.281 kilojoule. And second, A is equal to 1.603 second inverse. Now this numerical is also for homework. This is regarding about the numericals based on collision theory and Arrhenius equation. Remaining part of this unit will be discussed in the next lecture.